Hi everyone. Today we're going to cover rational numbers. We're going to talk about absolute values. And then the third thing that we're going to do is we're going to put fractions in order from smallest to largest. So after this lesson, I want you to be able to, like I just said, identify sets of numbers, and we'll go over all the different types, put your fractions in order, and then put your absolute values in order. So what type of numbers are we going to deal with this year? Well, we have rational and we have irrational. But I've got a graphic organizer here that hopefully will help you keep things organized. That's what a graphic organizer does. Natural numbers, what are they? Well, they start at 1 and they go on to infinity. So it's your numbers that you would count with. You don't start counting people going 0, 1, 2. You start at 1. Those are natural numbers. The second type of number is a whole number. It's your natural numbers, but it includes the number 0. A 0 looks like a big hole. That's what whole numbers are, and that's what they start with. And our third type of number that we're going to talk about are integers, whole numbers, and opposites. They're kind of all lumped together. They are positive and negative numbers, and they only include the whole numbers. They don't include fractional parts. So basically, it is your number line that you've seen since, I don't know, 5th grade, 4th grade. And then all of those numbers, as you see, fit into the category of rational numbers. Our other type of number, and we really aren't going to deal with them a lot this year, you'll see are up here. These are irrational numbers. What are irrational numbers? Basically, they're any number that never ends. So pi, for instance, would be an example, or never repeats. So it may go on like 0.1234 and stop, but it never repeats, so it's an irrational number. Rational numbers are, this category down here, are fractional parts. It's a decimal that repeats with a pattern, or it is a fraction. So we'll talk about these a lot more this year. I think you'll get the hang of it. Now let's talk about what type of, or what set of numbers do these items fit into. If you were talking about the number of siblings that you have, would you talk about rational numbers? No, I don't think so, because you don't have half of a sibling. This type of category would fit into whole numbers. You could have no siblings. You could have 1, 2, 3, 4. You wouldn't have negative siblings, so whole numbers is where that fits in. Amount of money in your bank account. Well, unfortunately, you could have negative money in your account. But rational numbers is where it fits, because you can have cents, which is a partial amount of a dollar. Golf scores would be integers, and then pi, I already told you, it's an irrational number. In the statement, is the following true or false? And if it's false, give me a counterexample. What is a counterexample? It's something that is the exact opposite that would make the statement true. So after I say each one, you might want to pause your video and see if you can come up with the correct answer before I give it to you. All integers or rational number. All integers are rational numbers. Is that true or is it false? It's true. And hopefully you got that right. Every multiple of 3 is odd. Well, I hope you know that already, but I'm going to give you a moment to pause and see if you do. That's false. The reason it's false is because you could multiply that 3 by an even number, say 2, and then you end up with an even number. 3 times 2 is 6. So here's some examples. 6, 12, 18. Those are called counterexamples. And our last question is, are all negative numbers, are they equal to or less than -1? No, that's false also, because -5/10 or -1/2 is an example as well, or a counterexample that shows you that that's true, and that makes our statement false. So now let's talk about something that's kind of confusing for middle school students. I want you to take these 3 fractions and see if you can put them in order from smallest to largest. If you want, pause the video now and see if you can do it without me telling you. This is a skill you should have covered last year. If you don't feel comfortable doing this on your own, then the best piece of advice I can give you is turn them into decimals. Decimals are easier to work with when we're putting them in order. So what does negative 3/8 equal as a decimal? Negative 375 thousandths, negative 0.375. Negative 1/2, negative 0.5 or negative 5/10, and negative 5/12 is negative 4,176 10,000ths. So now we have to put them in order. How do we put them in order? Well, you look at your first number. First of all, they're all negative. Then you look at your next number. You've got 3, 5, and 4. Which number is the smallest? Well, obviously it's 3. So remember, negatives go backwards. So 3 is the smallest, so it's going to be over here to the right. And our numbers get larger as they go left. They actually get smaller, but the actual number gets larger the further we move left. And these are those numbers in order. Okay, I want you to pause the video and try these three. Remember, one of them's positive. Go ahead and pause. Okay, now I said that we should put those in decimal order, or figure out what the decimal equivalent is. 1/12, negative 2/3, and negative 5/8. This is what you should have come up with. Hopefully you know that 1/12 is going to be the farthest one to the right because it's a positive number. Negatives move backwards. So we've got negative 0.67 and negative 0.625, or if we read them correctly, negative 67 hundredths and negative 625 thousandths. And they fit in right here because here's negative 0.60, negative 0.62, negative 0.68. The negative, or the positive 83 thousandths fits over here. And the last thing we're going to cover today is absolute value. This should be pretty simple. Basically, the absolute value of a number is the distance the number is from 0. So if I pull up a number line like that, and I gave you these absolute values, I want you to graph these on a number line. I would like you to pause your video and tell me exactly what the absolute value of these numbers are. Okay? If I asked you, what is the distance, or what is the absolute value of 8? It's always going to be positive. Distance is always positive. It's going to be 8. And this is where we would graph it. The absolute value of negative 9, if we graphed, we're going to go move down instead of across. So the absolute value of negative 4, here's negative 4, but how many spaces is it from 0? It's 4. And what about negative 9? That's over here. What is the distance from 0? It's 9. It's not negative 9 spaces from 0. And then we're going to move through these a little bit quicker. 2 is 2 spaces from 0. 1 is 1 space from 0. And negative 7, well, it's positive 7 because it's 7 spaces from 0. In review, what did we cover today? Well, we covered all the sets of numbers that we're going to deal with this year. Natural, whole, integer, and rational numbers. Those all are rational numbers. And then the odd group that we're really not going to deal a lot with this year, irrational numbers. We talked about how to put fractions in order from smallest to largest by converting them into decimals. And finally, the last thing that we discussed were absolute values. And basically, absolute value means what is the distance that the number is from 0. I'm going to give you 4 problems here that I want you to try. And come back to class with your answers. See if you can figure them out. Lastly, some of you may be asking, why does Mrs. Gokin have glasses on? It's because I can't stay looking at the screen, and my students make fun of my eyes moving every which way. And this fly keeps bugging me. So, if you have any questions, go back to class and ask your teacher. Hope you have a nice day.